You are here. Thank you for being exactly who you are and for choosing to do so with me today. Each of you has something special to contribute and share with the world, and I want to live in a world where you're able to do just that. I'm so glad you're here. In addition to you being here, I am here. I'm Hippie Hacker, and I invite you to bring your best ideas and hack the planet with me. Because we won't see what is humanly possible unless we invite everyone. So don't forget to invite your neighbors. However, it may require a shift in the way that we grow and share ideas from the gardens of our minds. In particular, we're going to need organic ecosystems of innovation where our combined digital produce can be shared locally and globally. So that's us. Now let's talk about ii. There is a special atmosphere when two or more of us put our minds together. And I think there is something quite divine in that. You're an I, I'm an I, and we're putting our minds together. That means ii is here. There's a viral generosity that happens when, by sharing something with others that is meaningful to them, they feel empowered and compelled to share it with others, just as I feel compelled to share with you what others have freely shared with me. I think that's why we're here. But to bring this a little more down to earth, software is basically executable ideas. And we are reaching a point globally where very complex ideas can be orchestrated across all our neighborhoods and nations. It's important that we have a shared understanding of what's required to execute and orchestrate these incredible ideas. It's going to have to go beyond those of us in the room of tech to provide meaningful expressions of innovation our communities need. Always buy local if you can. It helps create sustainable ecosystems of innovation. Each land has its own customs and protocols and even its own clouds overhead, producing innovation specific to that region and people. If we can focus on not just our own locales, but ensuring interoperability of ideas, this allows us to recompose them without needing to ask for permission. Local infrastructure developed and run by locals everywhere allows participation from all people and all nations. What will your community be known for? Free software, $5. I used to sell CDs at First Saturday Hacker Farmers Market in Dallas, Texas. I did quite well. Some weekends I'd make $300 just walking around and giving people what I had downloaded off of the internet on a CD that I could physically hand them in exchange for money. We don't use CDs much anymore, but the International Standards Organization had a ISO 9660 for CD-ROMs. That specification is still used by nearly every operating system that is distributed on the internet. From imagination to reality, our executable ideas and production workloads are going to require a new standard for distribution and orchestration. CD-ROMs just aren't going to cut it. To that effect, we'll need a decent ecosystem for defining and running those ideas and workloads all over the world. Innovation occurs best when with lots of freedom to recombine and improve on existing ideas. We'll need to have shared customs and protocols, in addition to the local ones, for connecting those new ideas with the infrastructure that can run them. However, this is going to require some global cooperation and some shared agreements. One might look at the CNCF Certified Kubernetes Provider Program as a certified organic provider sticker for clouds. What do you get when you see this logo? It means that the provider successfully passed the full set of conformance tests that aims to fully define what it is you should expect from Kubernetes. What is it that you should expect from Kubernetes is probably a reasonable ask as well. The CNCF has commissioned API Snoop to help understand the total API surface area of Kubernetes. It's used to ensure the APIs for infrastructure globally, it's used to ensure the APIs for infrastructure globally provide the behaviors we're coming to depend on. This sunburst graph from API Snoop represents the surface area of Kubernetes. That middle ring with the alpha, beta, and stable APIs is represented by the red, blue, and green. That second ring represents the various API groups of Kubernetes. And the outer ring represents each of the available API operations that all of us are using on a daily basis. If we zoom in and look at the green, those generally available APIs should provide a very stable surface area for us to deploy our ideas on. They will take years for those APIs to be deprecated, and we're currently only testing about 30% of the surface area for all of our CNCF certified Kubernetes providers. If we zoom in even further and look at stable core, there is a 70% gap in coverage. Helping to fill in the gaps in coverage is why API Snoop project exists. We haven't always had this level of understanding of the API surface area and cloud coverage, so I'll take you up into the clouds for a bit, back to 1960. In 1960, we had our first TV broadcast of the clouds above us from the satellite Tyros-1. If we go forward to 1972, one of the most famous selfies of all of us was taken from the crew of the Apollo 17 module. In 1990, the probe Voyager 1 traveled to 30 degrees above the ecliptic, looking back at our solar system, and sent a picture back to Earth that is referred to as pale blue dot. You probably can't see it, but in that third red band, about halfway down, you'll see a pixel that's slightly blue. That's us. By 2001, we had a lot more satellites, and we began to get a full picture of the Earth over time. And finally, a map with New Zealand on it. It often gets cut off. By 2002, we had enough satellites to get a clear picture of the entire Earth in one day. Over time, this allowed us to see the entire Earth without clouds. In New Zealand, there's a Maori proverb that reads, "What is the most important thing?" And the response is almost automatic. It's the people, it's the people, it's the people. So all of this understanding the surface of the Earth and the coverage and is mapping somewhat to our journey with Kubernetes. Ken Omichi wrote the first software that parsed our logs, just the logs of when we ran tests. And this exposed our initial 11% API test coverage. Thank you, Ken, for contributing that and being part of our community. Forward to 1.11, and Rowan Fletcher wrote the initial API Snoop. It was a man-in-the-middle proxy with a sidecar and our initial audit logger parser. He also implemented the sunburst graph and the logo that API Snoop is known for. Thanks heaps, Rowan. In 1.12, Zhongzhu added support for the API server for recording which software was making the API request to Kubernetes. This allowed us to update the IDE framework to include the name of the tests with each request. Before 1.12, we had no idea if endpoints were being tested and whether they were conformant or not. Thanks heaps for your time, Zhonghu. In 1.13, Devin Carpenter helped set up API-snoop.cncf.ci to process audit logs for our community's CI from Prow and Test Grid, and the results there gave us our first glimpse of coverage as it changed over time. We got to 114, and we had a real critical thing happen. Prior to this, features were getting promoted from beta to generally available to the public that didn't have any test. And in order for us to get coverage, we needed to stop that bleeding. Aaron Krickenberger, while serving on the 114 release team as a lead, had the foresight to implement a policy that GA features must have conformance tests. I agree. That's a big deal. Thank you so much, Aaron, for helping us keep our standards high. In 115, Zach Mandeville performed a major rewrite of our manual process of looking at Python and JSON into a beautiful Postgres and GraphQL API. This allowed us to start asking questions about our coverage and answering them without needing to write more tooling. We could just update queries and get a lot of dynamic information to help us comprehend the full API surface area and prioritize what we need to be testing next. Thank you, Zach. 116, Jordan Liggett improved our visibility by ensuring we see every generated event from any application. There were some bugs, and he found those, and I really appreciate that, Jordan. 117, we just had a release, and we still have gaps. And this is where you come in. We need to not only measure the surface area of Kubernetes, but we need you to be involved in prioritizing what it is that you do with Kubernetes and making sure that we have conformance tests for that. I have a bit of a demo that we'll walk through. It starts by bringing up a cluster that has support for dynamic auditing. So on the side over here, I'll bring up our demo. So our baseline and our kubectl create. So I'm going to call this Sydney today. And we'll have a terminal window where our output's going to go. It's going to deploy this cluster config that enables auditing. And we'll go ahead and fire that off. And as that's running, we'll go back to our slides. So when we create this cluster, it allows us to deploy API Snoop. API Snoop needs to be able to request that the API server tell us everything about the programs that are speaking to it. And the auditing webhook allows us to do that. We deploy a PostgreSQL database as well as a Hasura GraphQL endpoint. In order to access that information, you need to get into your cluster to connect to the Postgres and the Hasura ports. So here's some commands that you would need to type to forward that. I've taken the time of doing that in advance, so we don't have to wait. And we also have port forwarding for Hasura. Hasura has a way for us to explore our API directly. When you load API Snoop inside your clusters, it will go and retrieve the latest CI builds from Test Grid. That raw audit event table at the bottom, that's around 400 megs. That includes all of the events that were part of the conformance run. The Swagger includes all of the definitions of the API, and we combine those into generating material for us to query. If we look at our current coverage from our within API Snoop, we're able to see that our percent of conformance coverage is still around 30% as of less than 2 hours ago. We'd love for that to be higher, obviously. You can run a query against API to see what the latest which prow result you were retrieving, as well as a link to that specific job. Our workflow within the conformance test writing team is to try to identify what APIs need to have tests written for them next. Part of our flow is to use queries into API Snoop to define those. But it would also be great if people would run within their cluster their own applications to help prioritize what APIs they think are important. This is the result of one of those queries. Here are some operation IDs that have 0 conformance test coverage. Once you've found an API that you care about, finding the documentation would probably be the next step to create a test for that, or look at how your applications use that so we have a good story. The next step is to actually write a test. And writing your test, we have examples as far as how do we test particular portions in a different language. The IDE test framework is written in Go and uses Ginkgo. But as far as exploring what the APIs do, our team uses several different languages. Here's one in Go that we run. Here's another one where we have tests in Python. And we also have, I think, tests in JavaScript as well. After we ran those tests, I'll do that in our demo. So we're going down to, where is our run the test? There's write our tests. Here is run the tests. Here's our one in Go. And we'll see that the components are healthy. We'll come back in a moment. When we update and look at the live events inside of your cluster at that time, we can see that we have a table called endpoints hit by new test. Pretty simple. And if we look at all of those endpoints and specifically look at the user agents, we can see that the test we written, which we set the user agent to live component test, hits the 2 endpoints that we're interested in. I'll scroll over slightly. So we also have a metric for what would be the increase. So if we look at our test coverage, over here to the right, we can see that we increased our coverage by 2 points there. There are around 1,400 endpoints in Kubernetes in total, as far as the number of operations you can do. Approximately 400 of them are in stable. And those are the only ones that are part of the conformance efforts. Now that you've kind of seen the process of deploying API Snoop into the cluster, running some tester applications, the next question is, how can you help? Well, it's running it in your own clusters, identifying gaps in coverage that you depend on, and work with the API Snoop and Kate's conformance teams to fill the gaps in coverage. I'd love to help you get these things up and running, or help in writing tests, or have our team help to write the tests. Because there's lots of empty space out there in the endpoints in our coverage, and this is what we need to increase our coverage on. So that's all as far as the demo and the presentation. I'll open up the floor for some Q&A, and I think there's a microphone up here, if you wouldn't mind coming up and retrieving the mic. Okay. I think that's it. Thank you for your time.